broadcast is live.
We are live. Excellent. Well, we have to believe we're live. It says we are. Okay. Hello, everyone. I'm Maria Leonard. Welcome to Invented Futures as part of Bristol Technology Festival. This is the first New Tools for the Future conversation. Invented Futures is a research platform that is building a response to dominant ways the future is made. Invented Futures asks the following questions: what kinds of knowledge, systems, and capabilities are required to imagine and build alternative futures? And how might speculation, from thought experiments to fiction, to performance and prototypes, provoke dialogue and change? We invite the public to engage with its network of practitioners, and it's a platform for the public to engage with ideas outside of institutions. And these ideas will then empower communities, individuals, to stimulate small paradigm shifts around the public's capability to re-steer the future. So tonight, this is a conversation dedicated to tools and methods for thinking. So unleashing the potential for heading towards uncertainty, why we might want to do more of it at this time. It's important to remember that futures are not made only in the way they present themselves currently unfolding, and to try and pick away and question, or Invented Futures likes to try and pick away and question what some researchers have started to call the political construction of hopelessness surrounding the future. So the point of this conversation is to start to work out and unravel some large questions, such as what is the nature of the relationship between discovery and the future? How do we know what we know? How can we go beyond that? And what kind of knowledge systems are needed to keep discovering? And how does that affect us, the public, and the way we see ourselves? So can we learn the future otherwise? So why are we asking these massive questions this evening? While futures thinking is often less about predicting the future and more about exploring uncertainty. So particle physicists such as Antonella ask the biggest scientific questions imaginable and then devise ways to answer those questions. So if the tools needed to answer those questions don't yet exist, physicists develop what's needed. So for particle physicists, future projects will require new knowledge and to solve problems that we can't yet envision. And historians of science, such as Francisca, look at the relationship between discovery and society to see whether there have been particular mediums for transgressing boundaries of what is known, and how counterintuitive phenomena such as dreams, insects, microscopic processes, evolutionary processes, the nature of color are communicated and then become part of how people see themselves in the world. So I'm bringing these two perspectives together is interesting and important because Invented Futures are interested in creating tools for thinking, because these generate real, actual tools for experimenting, for action. Uncertainty rather than something to be conquered can itself be a tool, and these tools harness imagination, social understanding, as well as discovery. Well, I don't expect these massive questions to be answered. We'll create a space for these questions to be asked, and I think this has great value. Okay, we've got an hour to get through this big adventure. And first, you might like to introduce yourselves in any way you think is appropriate. I'll start with Antonella, if you'd like to go first.
Hello. First of all, thank you very much for the invitation to this very interesting conversation. I am a professor of physics at the University of Sussex. I work on the Large Hadron Collider at CERN, the largest particle physics laboratory in the world. I've been a particle physicist for 25 years and more, and so I'm interested in the search for new physics phenomena.
I can introduce myself very quickly. I'm Francisca Colt. I'm based at the University of York, where I'm a researcher in science communication. I have a background in the history of science, as well as in literary studies and storytelling and communication and media science. So I'm really interested not only in science and the history of it, but how we traditionally have made sense of the discoveries that science has presented us with, and how we can effectively communicate discoveries, challenges presented by discoveries in science, and how we can really do so in a way that takes everybody with us and that no one is left behind. But that on the other hand, we can also reflect a little bit on how this has been done in the past and what we can learn from that. And I'll talk a little bit about some examples that might help us along in that process later on.
Excellent. Okay, let's start. I'm going to start with Antonella, just so we get a view of discovery and making sense of what discovery is. So your work at the Large Hadron Collider at CERN on the ATLAS experiment, I would love to hear more about your work there. And so would you say it's accurate to say that this kind of work is based on scientists thinking of things for the experiments to look for? So they're scientists that are creating questions for those experimental tools to look for.
Right. So you can think of particle physicists in two broad categories: theoretical particle physicists and experimental particle physicists. I'm an experimentalist. So, as you rightly pointed out, we build these experiments to answer questions which are typically posed within some theoretical framework. And we have a very good theoretical framework, which so far has been proven quite difficult to break. We like to break theoretical predictions because that's the way in which we advance our knowledge. It's the way in which we push the boundaries of what we know beyond the current paradigm. And we do this as particle physicists by looking at the smallest distance measured by mankind. And the way to do that is to collide very energetic beams of particles. We collide protons, which are nothing else than hydrogen atoms stripped off of their electrons. We take them through various acceleration stages to very high energies. And by colliding them head on, we smash them on, and new particles are produced thanks to Einstein's equation that links energy to mass. And we look at the products of these collisions to see whether nature behaves in the way which we expect from the standard model, or maybe there is something else beyond the standard model. You might have heard that we discovered now nearly 10 years ago the Higgs boson, which was the last building block of the standard model. So there is a search for phenomena that we expect. The Higgs boson was to a very large extent expected. The whole framework worked beautifully, and that was the only bit that was missing. But on the other hand, if we hadn't found it, we would have had to find the reason why it wasn't observed. We found it, and now we have to ask ourselves the question, is this the particle that we expected? Does it fit all the various predictions of the standard model? Is there something in the measurements that we perform that goes beyond what we expect? And then there is another approach, which is to actually search for new things, but at the same time, we need a framework to search for those new things. So one of these frameworks, for example, is supersymmetry, but there are many other theoretical models that go beyond the standard model of particle physics. And that's what kind of really interests me. I like to search for these beyond the standard model possible phenomena that might be realized at the Large Hadron Collider. But the important thing that I also want to point out is that we have to frame these kind of questions by in a manner that enables us to falsify them. So if we don't see something, then we are able to exclude those those predictions. And even though we didn't discover those new phenomena, the ability to say those phenomena do not manifest themselves in nature, hence this theory can be excluded with a certain level of confidence, is per se a very important step towards the advancement of knowledge.
And how would you go about creating those questions for those experiments?
So you might start from some phenomena that you know, the standard model, and then you will have simulations or predictions from the standard model. So you have to develop simulated models of the phenomena that happen in your detector, then make predictions about certain physical quantities that you measure. Then you measure those quantities, you compare them to your predictions, and you look for discrepancies. And it's very important that your predictions are reliable. So we rely on modeling, but also we rely on data to tell us if our modeled predictions are in fact robust. So sometimes we have to use what we call data-driven methods to estimate those background. It's a bit like when you're trying to, old-fashioned radios, you're trying to look for a signal and there's a background noise and you have to tune to the right frequency so that you have that signal. So you need to be able to first identify the known, the standard model, and then to characterize what the unknown may look like. And then we collect huge amounts of data and we measure lots of properties of those data. And so you go about identifying what properties may look different for the new physics with respect to the known physics. And you have to have enough of those differences to be able to state that you see maybe a new signal with some significance. So statistical analysis of our data is extremely important. The concept of establishing significance of a signal is very important because you want to make sure that if you make, big statements require big responsibility. So if you're claiming that you're seeing something new, which might be worthy, say, of a Nobel Prize, just to put it in kind of layperson terms, then you need to be able to prove it beyond any reasonable doubt. So you want your significance to be as great as possible. And there are mathematical methods to measure that significance. Once you understand your detector very well, your modeling very well, and once you understand if there is any bias in your selection of phenomena. So your selection is to be robust, reproducible, unbiased, and significant.
And where do you put the role of the experimental? Where would you say that becomes most clear?
Well, as far as I can see it, as an experimentalist, of course, I have the bias of an experimentalist, right? But for physics to be physics, it needs to be supported by data. Otherwise, it's very beautiful, very interesting mathematics and very clever kind of ideas. But for as long as they're not grounded in experimental data, it's not physics. So the role of the experiment, in my view, is fundamental in two ways: to essentially stretch and stress test, let's say, theoretical kind of predictions, but also by the observation, for example, of new phenomena that maybe had not been predicted before, to force the theoreticians to think about explanation. So we have sometimes what we call anomalies in our data, that once you've kind of convinced yourself that it's not an experimental effect that comes maybe from the malfunctioning of some detector, or maybe your limited understanding of some systematic uncertainties, once you're convinced that there is a true effect that you're measuring and that that effect does not agree with theoretical predictions, then that's the most exciting time for theoreticians, I guess, to go off and think about their models. And then they need to come back to us to say, okay, now that you have this anomaly, we need to figure out what it is. And there again, another experiment, or maybe the same experiment, will have to probe whether the anomaly corresponds to some specific model. And that's when you go about falsifying some hypotheses, and then by exclusion, at some point you'll be able to say, within reason, I think this is it. Maybe there is something bigger beyond that, but this particular framework now fits the data as well as we are able to.
Excellent. I'm really interested in how this reiteration of experiment kind of conforms to this framework, and at the same time you're kind of making the framework as you go along, but it's all tied to this robust, concrete.
But I mean, if you think about the history of particle physics, for example, you will find that, and physics in general, it's kind of a constellation of falsifying the current knowledge and going beyond the current knowledge. That doesn't mean that you take the baby and the bathwater and throw them away, right? You just say, okay, in these particular conditions, that approximation is valid, but I've now proven that it is in fact an approximation, and I need to use different kind of tools. For example, if I want to describe the physics of very fast objects, I need to use special relativity. If I want to describe the physics of the very, very small, I need to use quantum mechanics. But if I want to describe the motion of a car or the falling of a stone off a cliff, Newton's mechanics is perfectly valid.
Yes, I want to bring in Francisca now. And I think I want to ask you about this kind of idea of articulation and clarification within public of theories. So how is that translation made? So if I'm correct, then your research looks at sense making and at the same time making strange. So showing us the stories we make of our relationship between the natural world and us. And I just want to try and put into dialogue you with Antonella. So I kind of want to ask you, what do you think, what you see as the relationship between scientific discourse, all of this pushing knowledge to its, to its far reaches, and culture, so people, individuals, our sense of being together.
Yeah, those are lots of really big questions. But I'll perhaps start with what you said. How do we deal with sense making, and how do we look at the history of science in this discourse, and how can we put this into discourse with into conversation, into dialogue with what Antonella's just said. And I think what Antonella's just been doing was really brilliant. She described the way in which she works as a particle physicist, but having heard this, imagine you hadn't heard this, and you'd gone out into the street and you'd picked up 10 random people and say to me, what does a particle physicist do? And have them explain how physicists work. Like, don't even take a particle physicist, take a scientist. Say, what do scientists do? How do scientists create knowledge? Very often, when we look at public science discourse, what we hear is a language of, scientists create facts. So we have a scientist, they go into their lab and then they discover something, and then we have a fact. Brilliant. Then the scientist goes into their lab the next day and discovers another fact, and they heap facts onto each other, and then we have science, and science explains the world. Brilliant. Really neat. But I want to pick up something which Antonella said right at the start of our discussion. As particle physicists, we like to break predictions. And that's really interesting, because that speaks really interesting to public discourses about scientists and creating knowledge. We think very often when we read popular stories about science, when we look at the history of science and the great discoveries in the history of science, we think of scientists as somebody who creates certainties. That misleads us very often into thinking that science is something that's monolithic, that's you can't shake it. It creates facts. Those are immutable. Those just sit there, and you can't argue with them. You can't argue with scientists. The scientists are sort of described as a sort of bunch of people who just create unshakable knowledge, and that really grates against what Antonella so beautifully described what scientists actually do. And it's really interesting. My work deals a lot with how science is perceived, how stories of science are being told, and how that shapes the public understanding of science. And that example I've just given about how science is often characterized in the public domain really shows us how making sense of science, as you put it in your question, it really draws attention to that sense is really something we make. It's not just ostensibly there. It is something that we do as a cultural thing. It has something to do with storytelling. And very often we perceive science, when we talk about it in public discourse, as something that's so unshakable and so different, an entirely different domain from things as flimsy as culture, history, and storytelling. But what that really shows you, the way in which we talk about science, really influences the way we understand it, and really actually can actually inhibit the way we understand how science is really being done, as Antonella described. A process that's done by very, very many people who work in different disciplines, that push each other, that test each other, that constantly put pressure on a system to say, is this fact, that discovery that's just come out, does it actually work in this system? Does it work in this other system? Will it work in these circumstances? And constantly push and break and refine and push boundaries and push us further and further and further. And how scientists don't always create certainties that we so crave, but often create uncertainties. And that is really something that is a discourse that we're very keen to change, that we're very keen to develop a rhetorical toolkit for actually confronting. Because when we hear uncertainty, we're often afraid. We go like, no, I don't want that. I want certainties. I want the scientists to rescue us with their discoveries. But it's actually so beautiful the way Antonella just described this, that, I investigate, why do we not talk about it the way in which scientists themselves very often do, but in a way that misrepresents science, and yet it's very frequently done because it's a popular way of talking about science.
Yes, I think this moves nicely into the kind of second section that I wanted to get to, which is I really wanted to think about the role of counterintuitive ideas. And so the process of turning an idea that seems to us to go against something, and how those, if there's a process where those ideas are explored, and if it's happening now, or whether in the history of science communication, whether this has happened. So I think, Francisca, can you perhaps tell us more about the kind of value of exploring uncertainty, and what happens when counterintuitive ideas are explored in the open?
Well, something that's, for instance, counterintuitive in science communication is something that I talked about just now. We very often hear stories about, so I use the word story here quite consciously when we talk about the history of science. And those are two different things. There's two different terms I'd like to introduce at this stage. Firstly, the history of science, and secondly, the historiography of science. Things that happened, and how we write about things that may have happened. And so very often when we go to the history of science and popular histories of science, very often tell us these stories of the great men of science, and there's very often men for some strange reason, and where scientists are described as some sort of genius that just discovers something. We very often talk about, even when we try to revolutionize these narratives, when we try to introduce women into this discourse, seen this a lot with the great women of science and lots of women inventors and so on. When we describe them as some sort of genius and someone who creates this fantastic thing, and then someone comes along and actually says, well, this is not actually quite how it worked. A very counterintuitive thing in science communication is talking about scientists as heroes and saviors and geniuses is actually really, really counterproductive. In a way, we feel like, we want to say these are very, very clever people, which they are. But in a way, as I've just described, for instance, talking about science as something that creates certainties and that these certainties are completely unshakable is actually really counterproductive. And I think it becomes easier to understand when we talk about an example, practical example, for instance. So my current work deals a lot with the whole discourse around coronavirus has worked. But before I came into this work, I was working on climate change. And in climate change, you can see this really, really clearly, how this narrative plays into the hands of people who actually want to discredit science and say, well, scientists don't actually have any idea at all. They're all in some sort of elitist conspiracy, and I'll show you why. So when we create a discourse in which scientists create unshakable results and monolithic facts, we come to a point, which Antonella described, where we model things, where we have data and modeling, and we combine things and we push things and we refine things and actually make our models better and better and better. But then we have newspaper journalism that says, let's say, in 2000 and something, we will have 3 degrees more global warming. So fast forward by a few months or a few years, and another group of scientists who have refined a model and said, we've got better results now. We can say actually 10 years earlier, we will have 5 degrees of global warming. And then you get people who want to discredit science, who take this and say, well, look, scientists don't actually know what they're doing at all. Some of them say it's 3 degrees, some of them say it's 5 degrees, some of them say it's 15 years, some of them say it's 30 years. I thought scientists are here to create facts. And if we fail, for instance, to say, well, it's not just about some lone genius that sits in their office and comes up with some genius idea, but it's really when we fail to communicate that scientists work as a team, that it's a process, that it's a constant process of pushing and refining. If we fail to communicate this, we actually make science and scientists vulnerable to be targeted by exactly those narratives. So what we think is a really great way of elevating scientists and, in society and what they do actually pans out as the opposite. It's actually quite harmful because it can be weaponized very, very easily by those who want to damage science. So that's a really counterintuitive thing in science communication.
Is it okay if I pick up on a couple of things that we just? So that's a really interesting point, and I fully subscribe to this idea that the general public sometimes likes a hero and likes a villain, right? So if we have this dichotomy between the hero and the villain, and the scientist can be either in people's minds, of course, it can become very dangerous. But also, I wouldn't want to go away giving the impression that the fact that we refine our models, that we refine our understanding of nature, means that whatever we said before is rubbish, right? You can still use predictions that you made previously in the right circumstances. And yes, indeed, we do refine our models. Sometimes we have to backtrack from previous statements, but there are facts. We do dwell in facts. It's not immutable, but it's not fickle and completely changeable all the time either. So I think it's important to assert the ability of scientists to state facts and to, for example, when we assert a fact with a certain level of confidence, which kind of may sometimes give the impression, are you confident? Are you not confident? Are you certain? You're not certain? It's like if we use that in kind of scientific jargon with the general public, it can give the wrong impression that we're not sure what we're doing. We don't know what we're doing. Well, in fact, what we mean is some very specific statement in terms of probability. But nevertheless, the assertions that are made are grounded in experimental facts, in theoretical facts, in reproducibility of experiments. So I would like to just qualify a little bit the idea that, yes, we are refining our knowledge all the time. Yes, we try to break models, but nevertheless, it is possible for a scientist, talking about the coronavirus, I'm not epidemiologist, I don't portray myself as anyone who can kind of make terribly well-informed statements about epidemiology, but I dwell in data analysis, so I feel like I can make statements around that. And the same with climate change, right? There will be a point where you can always find the kind of loner person who wants to counteract the general consensus, but it's again this media strategy of polarizing the discourse that can become dangerous, not so much the fact that people are trying to refine their knowledge.
Yeah, and so this is really, as Antonella just says, there's a really, really interesting thing becoming. So one of the things that we work on is this process of making sense, and it's exactly as you say, being able to tell apart where narrative starts. Where this media strategy starts. We like a hero and we like a villain, and we see this in history. So we've seen a lot of historical reworkings of scientist heroes and scientist villain. If you think, for instance, about stories that have been told about Edison and Tesla, that's always the hero and the villain, the entrepreneur, the underdog. And what stories are actually behind this? Where's the actual history behind the storytelling here? And it's really, really important to start becoming sensitive to those narrative strategies and how we talk about science, how we have in the past talked about science. And, are there really these heroes and villains in these stories, or what lies beneath this? What actually goes on there? And I think this is really interesting. And that's why I think it's so important that we change the discourse about science a little bit from the way in which it has been conducted, because it's exactly that. We have those preconceived narratives. We like to smack on stories of science, but they very, very rarely accurately represent what's actually going on in this sort of discourse.
One great way to change the narrative about science is to educate the general population about science, right? If people were numerate and they understood statistics and probability, and they made sense of the numbers that are sometimes spouted out from news outlets or politicians, if there was better knowledge of science, it would be, in my view, less challenging to change the public discourse around science, because everyone would then feel some kind of empowerment and the ability to discern and not take science as some form of religion in which you can either believe or not believe, right? You would be able to act as a scientist and understand science communication as science, and make sense of it without necessarily the need of some sort of priest figure that, or rather prophetic figure that tells you how it is today and it may be wrong tomorrow. So if there's something that, for example, I would wish for the general public to take from the attitude of, say, particle physicists, would be like a critical sense towards the interpretation of data and information that comes along. Going back to the situation with the COVID pandemic, the outbreak, it was clear to lots of physicists and mathematicians who were looking at the rate going up and who were used to look at logarithmic scales. Now everyone has seen a logarithmic scale and knows what an exponential growth means, or at least they think they do. But it was clear to a scientist that was going to explode very soon. And if the public had been better trained, I guess, to read the signs in the data, maybe something could have been done better in the early stages of the pandemic.
So So yes, I think I think we're sort of moving on a little bit in the questions, but I think so one thing that we're also interested in sort of counterintuitive measures is that science communication has sort of many legs. So scientific education, communicating the actual science, is one of them, but also one term that Antonella used, and that's really important, is the sense of empowerment. And so I really love the language that Antonella has just used, namely that this sort of talking about science as if it's some sort of religion that you can sort of choose not to believe in is really unhelpful, and seeing the science as a sort of prophet, the scientist as a sort of prophet, is really which is sort of what I was driving at. But I love the language that you were talking about here. When we shift from that sort of idea of having the scientist as a sort of on top of a mountain or a pedestal, depending on how you talk about this, to the empowerment scale, one of the things is you can tell people, these are the scientific facts, this is what they look like. But then I think another leg is the empowerment, is the sort of how does it work around you? Because one of the things that I am always keen to emphasize is we sort of should move away from this idea of science is only something done by a scientist in a lab, but we all can know the science and see it working around us. And that's the point where I think we're sort of getting to. We need a conversation in which we can all think and act like scientists. Scientists is not just for someone in a lab, but for everyone to understand and for everybody to discern. And in terms of climate change, one of the areas in which I previously worked was, for instance, the biodiversity crisis. Which is one of the things you can really, really easily explain, because everybody's seen nature. They have an understanding of what biodiversity looks like or should work like. But when you then just very slightly adjust the way in which you look at it and point out certain things that might seem really surprising to you because you've seen them all the time, but suddenly you see it through different eyes, you have the agency to see change, to detect it, and then actually to yourself assert, well, perhaps this is what we need, and enact change yourself. And I think that's one of the most empowering ways that you can actually communicate science, is to bring people into the boat and let them, work the boat themselves. Not that I'm saying everybody can become a particle physicist overnight. I would probably struggle with that, but I think you get the idea here.
Yeah, I think this is a really excellent point to get to the next stage in the conversation. So the original point of counterintuitive ideas being explored in the open, whilst being in dialogue with counterintuitive ideas being, found or measured, cultivated, discovered within experimental labs and so forth. We're trying to get to this point where we're thinking about what might a new kind of landscape of public knowledge look like, I guess, where the public imagination is an untapped source. If we sort of take on this point of empowerment, there's this idea around futures literacy in certain fields of research, where you think about how do you create thinking towards what's happening around you? What are you doing in that space, and what are you doing through education? And I guess I would like to ask Francesca again, is there a version of futures literacy that you're interested in particular? What kind of framework that we can take comfort in? I mean, I guess if I turned up to the climate change summit at the end of October, I don't think I would see much speculation or fantasizing or daydreaming. So what do you see as this public knowledge space? What would you like to see it as?
Well, I think one of those, I think there's the role of the imagination is sort of what we're driving at, the role and the value of the imagination and of speculation in science and in science communication is sort of the question that we're asking. And I think this is and especially in terms of climate change, this is a really it's a thing that's greatly annoying me, because I think on stages we very often see people like, oh yeah, we have a plan, it's definitely going to work, here it is, and it's all fine. And I think we're all a little bit tired of hearing that sort of narration. When I was working, one of the projects I have worked with in the past was one specifically, as I said, on biodiversity crisis, but especially one on the decline of insects in recent years, and how insects are actually really important. So insects are one of those topics that generally, when you bring it up in sort of adult public audiences, people go like, oh, I don't want to talk about insects. And that's a really difficult thing to overcome. So we had to develop a strategy in order to involve people who don't want to talk about insects and who are not interested in science or hearing about biodiversity crisis in a way that makes them care about it and makes them feel that they can personally do something about it. And our way of doing this was through children's literature. This sounds, again, like a really counterintuitive thing, but if adults don't want to talk about something, children usually react to insects very, very differently. So when you hold a massive spider or a massive grasshopper in front of an adult face, they usually go like, oh no. When you hold it in front of a 5-year-old, they go like, oh, cool. And suddenly you have an audience. For reflecting through insects and how they appear in children's literature, take Roald Dahl's James and the Giant Peach or something like that, and saying, well, did you actually know that these people did quite a lot of research into insects and were quite concerned about what's happening to them even at the time they were researching their books? And then you say, well, look, these amazing things that insects can do in these books and what they actually do in our nature, and what actually happens when they don't do this in nature, and why is this happening? You talk about the way in which cityscapes and urban landscapes have changed, how there's fewer vegetations and fewer areas for these insects to live, how these areas are affected by pesticide spraying and things like that. And suddenly you give people an idea of how this happens very much in their own backyard. And they say like, oh, wow, I had no idea that the way in which I sort of navigate my own garden, that the city that I walk through every day on my way to work is designed, actually affects us as humans, our society, in a bigger scale. And when you draw them back to these stories of discovery and explorations that they used to love as children, that's a really, really effective narrative strategy, because not only are you discovering these facts yourself, you are then also feeling empowered. You know what you need to do. You can change things in your own back garden. You can petition your local councillors to say, well, why don't we have a few more wildflower meadows, and actually create change in the world around you, and not just hear these apocalyptic stories about we're absolutely doomed, climate change is inevitable, there's nothing you can do about it, because this is not going to make us change the way we interact with the world. But there are ways of doing this. And this is why we see, for instance, in wildlife documentaries that have brought such issues as public plastic pollution in the oceans to our attention, such as David Attenborough's documentaries. This is why they're so successful, because they employ this narrative strategy. And if you tell people, we need to treat you like a child, they'd go like, no thanks. They'd probably walk out. And because we are in a society where we sort of condemn the childish and the imaginative and fantasy and science fiction and say, yeah, fine, this is something for adolescents. But actually these narrative strategies are something that we respond to very, very well, and they give us the room to think through these bigger problems and how they affect the worlds in which we live. And I think that's very, very valuable for communicating the things that are at stake here.
Excellent, interesting. So I want to get back to Antonella, try and put this in dialogue again. What about your area, so particle physics? What one tool for thinking, or a few tools for thinking required in particle physics would you like to encourage in those of us attempting to figure out our place in uncertainty and crisis and anticipated futures?
Well, I think to be a particle physicist, first of all, you have to, you can't expect the world to become particle physicist, and it wouldn't be even helpful to transform the whole population into particle physicists. But some of the methods, in fact, I dare say, a lot of the methods that we use as particle physicists are very helpful. One is the ability to abstract, to generalize, to look at patterns and discover patterns and be able to sort out patterns and verify your hypothesis. And this is the scientific method, but in particle physics, you cannot look at photos of stars, you cannot look at photos of magnified images of microbes, or you can't look at insects. It's all very abstract, and that has a challenge in itself, because you have to kind of train your brain to use mathematical tools to give a shape to nature. So that ability, I think, is very important. The ability to look for patterns and to kind of verify your hypothesis through confrontation between expectations and reality. But then, and I was mentioning this just before, the ability to, I mean, we analyze large samples of data. We talk about big data all the time, and big data is everywhere. Social media, whether we realize that or not, is essentially a mine of large amounts of data that is analyzed and used to steer us in some directions or another, to have a more scientific or a less scientific frame of mind, to approach emergencies and future problems, which may not be another pandemic, but maybe some other crisis, right? Information is sometimes steered in one direction or another using data and manipulating numbers, conveying numbers in a biased fashion. And so it seems to me that the ability to look at data, to identify biases, to understand the meaning of trends and averages and significance, and what a confidence level might be, the fact that you can make a statement to a certain degree of certainty, and even though you can't say this is 100% true, you can have a large confidence in that statement or not, and be able to assess, for example, in life and in political decisions and reaction to crisis, based in statistical information, I think is very important. And so I would very much like that that ability, that skill, that set of skills became a lot more widespread than it is, so that kind of priesthood element of manipulating numbers was removed by kind of widespread knowledge.
And I think that's something, if I can hop onto this, recognizing patterns in a very sort of scientific, neutral and sort of way is really, really important in communication science as well. Patterns, narrative patterns, exist in language, and very often, and we talk about sort of fallacies and distortions, you know, when Antonella was saying we're misrepresenting numbers, the way in which this is done is usually done by storytelling, and there are very often interesting ways of sort of dropping some bits and focusing on some and not looking at bigger pictures and so on. Very common strategies that are applied again and again and again, that we can sharpen our gaze for. We can see, aha, this is a really common way to discredit knowledge. Let's see what's behind there. And so when we start recognizing patterns in language as well, we can recognize these patterns of narrative that want to distract us from something, that want to polarize. And very, very often when these patterns are applied, someone is probably trying to sort of misrepresent something. So we can learn those patterns in language of misrepresentation. And so developing scientific patterns, pattern spotting habits is actually really useful in looking at language as well, and linguistic and historic discourses.
If I can give an example, sometimes large numbers, I used to say, oh, this is really, I don't know, very dangerous. A billion is a large number, right? We understand it to be a large number, but you need to have a comparator to be able to say whether a number is large or small, and to have that automatic reaction to say, all right, this is 30%. Is that a large number? Is it a small number? Is one person killed in the street per month a small number or a large number? What was the number on average this year? To have that automatic mechanisms in place so that we can discriminate between exaggeration and kind of just plain facts and statements with uncertainties. I think that would be a very, very helpful.
But is there something quite interesting about uncomfortable knowledge? So perhaps understanding that acts as a gateway, a starting point, an end point, some things that are mistakes, that are coincidences. So if we prove the limit of something, that can almost be helpful. Would you put that in your toolkit, that kind of thinking, Antonella?
Well, we stand on the shoulders of giants, right? What we learn is built on the knowledge of progress in, say, science, but generally speaking in kind of general knowledge, but also in the knowledge of the mistakes that were made. So everything can be an arrival point or a starting point, depending on what trajectory you're taking, and also what kind of questions you're asking. So to be comfortable with this idea that something can be not wrong or right, but rather can be better adapted to describe this situation, or better adapted to describe a different situation. The example that I had before, do I need to use quantum mechanics or special relativity to describe the motion of a car? No, I don't. That doesn't make it any less valid. It's just that it's a bit of a overshooting. At the same time, to be aware that there will be situations in which I need to use the better refined, the more sophisticated toolkit is important. So that is where, like, the starting point, the arrival point, and also talking about mistakes and misunderstandings, and also the serendipitous aspect of even discovery. Sometimes mistakes are made, and the exploration that comes from a desire of figuring out what the mistake was and fixing that mistake then takes you to unexpected places scientifically, and you make new discoveries that you were not planning or expecting even to make. You might be planning to perform an experiment to discover a certain physical phenomena. There was an experiment that was trying to figure out whether the proton is an unstable particle that decays, and that same experiment never made a terribly important statement about the proton lifetime, but they discovered new physics phenomenon that is called neutrino stellation. So from kind of not having the right kind of experiment to, or not, maybe not the right kind, but not yet the sufficiently sensitive experiment to perform a certain exploration, you find yourself finding something completely new and unexpected. Another discovery that was made of the cosmic microwave background happened because the scientists at Bell's laboratory, they were trying to use certain antennae, and they thought that they made a mistake, and there was bird poo in the antenna, and they cleaned the antenna and all the rest of it. And then it turns out that there was this microwave background in the whole of the universe that points to the Big Bang. So everything can become a starting point, or it can just turn out to be a plain mistake where you forgot to label a certain cable correctly, and you got, I don't know, you think you discovered superluminal neutrinos or something silly. So it's a two-sided aspect of what we do.
Interesting. I think we're nearing the end, so if you do have questions, please ask them now, if you do have them. I think if there are not many questions, then I think I want to ask my last question to Francisca. I think I read, or perhaps you were talking about something where you said, take any field of science that has ever been contentious and you'll find a scientist writing a fairy tale version of it. Why do you think, I think to wrap this all up, why do we come back to this sense making?
Because I'm not quite sure where the fairy tale version came from, but I think one of the things is I think in the conversation that we've just been had, I think one theme that has come out really strongly is the sort of challenging of preconceptions and the sort of ways in which we think we understand the world. And challenging that. And it's that, when Antonella said, when you asked the question, Antonella, what do you think as a scientist, as a particle physicist, is the sort of toolkit we should bring to the future, we should bring towards, perhaps into the non-scientific world. When you said, testing hypotheses and sort of what you said right at the start was something about, testing preconception, testing predictions and trying to break predictions and trying to break the ways in which we think, like sort of put pressure on the ways in which we think we understand the world. And I think that is something that science and science communication and the historiography of science and the history of science have in common, challenging what we think is true and testing it. And, as Antonella said, I wish people were more sensitive, would develop a toolkit for being more sensitive of detecting where someone is sort of distorting something. I think this is the sort of tool that I would like to put in the toolkit for the future of how we engage with science. And I think this is really interesting because one of the questions that you asked me when we prepared for the project is where is there a place for science communication, for storytelling, for the imagination, for literature and science. And that's exactly it. That is the place for it. This is what we teach. We teach communication. We teach how to read narratives and become sensitive to, this sort of stuff being in action, the scientific principles being in action in the way in which we communicate and the way in which we write about who we are, how we relate to the world around us. And just that tool, developing the toolkits to sharpen our gaze, to sharpen our senses to that. I think that is something I would like to put in the toolkit for the future, especially in an environment in which we increasingly hear again, and this is something that sort of periodically comes up in history and is currently coming up in the present as well, that there's no room for degrees like social sciences and literature and communication science and media science, that those are sort of low value degrees. But one of the things that I always ask myself is, as this discussion today showed, it is actually really valuable to teach these things and how to spot these things, to develop those pattern spotting skills. Why would someone not want you to study this? And so I think what this discussion brought out today is that we do really use similar tools in very different areas that, however, overlap. And I think that's where all hands on deck are needed, and we shouldn't be chucking anyone off that boat.
Absolutely. Very interesting to see how the methods, even though in very different contexts, the methods are very, very similar, and the frame of mind are very similar.
Yeah, that's a great point to draw a discussion to a close, I think.
Absolutely. I guess I was a bit tentative to use these words such as methods and tools, but because they're quite removed, they're quite abstract, they're almost, they're terms really that can be used as like plasters or to fix problems. But I think, yes, as you've both eloquently said, these terms are themselves useful in order to create this dialogue, I think. And I think if we understand more about what seemed possible historically, such as the implications of quantum theory, superstring theory, and if we try to encourage a kind of public landscape where we understand this, then we might then start figuring out tools for tackling uncomfortable truths, such as the emerging effects of automation, the implications of viruses, the kinds of technological solutions to the climate crisis, because of course, there is the scientific understanding which continues to run ahead of the social and political response, really. And so I think it's, I think using these terms, we can create this dialogue and to really underpin the value of uncertainty in both of these areas that are often put in diametric boxes. If there are no questions,
I think we have questions. Unfortunately, participants can't see them, so I'm wondering whether our tech support could perhaps helpfully convey them to us.
Oh, yes.
But in the meantime, while we try to figure that out, I think one of the things that is important here, and I think something that Maria just pointed out really interestingly, is that you were wondering whether the words like methods and toolkits are that those words are appropriate to what we're discussing here. Well, they are metaphors, aren't they? And
yes.
Metaphors are all over the history and the communication of science. You know, think for instance, electricity. We think of electricity in currents. That's a water word. Why did Faraday come up with that word? Faraday reflected very consciously on that, and he reflected on this when he named the anode and the cathode, which are Greek terms for, you know, for the electrogram, which shows us how the electricity goes up and down. And electricity doesn't really go up or down or anywhere. It's not a current. It's not made of water. It works completely differently. But why did he use words like that? Well, he used words so we can imagine what it might be like. It's like a model, so we understand what it might work like, and so he can understand. He used those terms for us to reflect. But interestingly, we use metaphors a lot, and very often we don't reflect on what they mean. When, for instance, we were working on coronavirus and government communication on it, and we talk about the first and second waves of coronavirus. Again, we've got this water thing, like what happens to us when we think of us confronted with a huge wave? When we talked about, you know, the battling coronavirus, the war against coronavirus, weapons against coronavirus, how does that make us behave in relation to the virus? It became really interesting when we started reflecting on how different languages conceptualized COVID and how that made people feel and how that made people behave. So again, thinking about whether such terms are appropriate and whether the terms that we use in scientific discourse are actually appropriate for the areas to which we apply them. That's a really, really interesting skill to put in our toolkit. Again, reflection here.
Mm-hmm.
So I'm wondering if we can see the questions now.
I can't. I don't know if I can see them.
There are no questions, I don't think. But that's okay. I think questions should go in the toolkit as well. Or perhaps the act of questioning.
Yes.
Questions, the act of questioning, they're related, at least. Okay, and would either of you like to kind of share what you have coming up that you would like to highlight, that we can find you experimenting with?
Well, on my side, the Large Hadron Collider has been what we have known as the long shutdown number 2. So the collider has been refurbished and it's now coming back to life, better and more powerful than it was. And so we should be resuming data taking in 2022. And that is very good timing because I'm really looking forward to be able to go back to CERN on a regular basis. It's been nearly 2 years stuck in the UK. Not that I don't like the UK, but I really miss the ability to go to CERN regularly. So I'm really looking forward to be able to do that soon.
Excellent. And Francisco, is there anything?
we're just preparing to go out to COP, to have those COP26, to have those conversations, though, to have those speculative conversations, to have those reflective conversations on how we confront the things that are being discussed there, and what do we do with the stuff that comes out of those conversations. And one of the things that we've been working on through the COVID crisis, but also one of the things that we're currently working on in our project is reaching out to all sorts of communities via community leaders, for instance, such as religious groups, various churches. So this is really interesting, because very often, and we talked about sort of preconceptions and things that we very often put into opposition that don't go together in our public imagination. Often when I talk about science and the church, people go like, "Ooh, does that go together?" And that's actually one of those areas when we were talking about science, and we have a project which is called Scientists in Congregations, when we bring scientists into churches and put them into conversation with church leaders. This is something that's extremely well received. That's always an absolute success. We've been having conversations over COVID-19, over communication, science communication with scientists. We're working on areas such as AI, genetics, and in the case of what we're doing just now, climate change, where we work with community leaders, where we work with religious communities, for instance, to think about how we can communicate this in the communities that we're in. Because one of the big things in science communication is, the one thing that really matters is trust. You need to be able, you need someone to communicate who is trusted, or you need to create trust, and creating trust is very, very hard work, and trust is easily lost. So finding communities that are, and people in those communities that are trusted, and equipping them with the tools to communicate well, to communicate the right things, and to do exactly those things that we're discussing with Antonella right now, communicating the scientific facts to educate, but also to say, well, let's confront of the fears we're having, the challenges that we face in communicating uncertainty and things like that. And there's something really great called the Uncertainty Handbook that's been developed by a climate change group. And if you face any of those challenges in your own workplace, I can only advise you to look it up. It's free to download as a PDF, and you can distribute it easily. And that's the sort of things that we'll be doing. We'll be creating those spaces in which people can come and say, but what does it mean? What do we do with this now? And ask those questions and explore them and guide them through them. And that's what I'll be doing in the next few weeks.
Excellent. Well, thank you to Francisca Colt and Antonella De Santo. Please join Invented Futures for conversations on other tools and methods for thinking and doing in the near future. We have just started speculative fiction writing workshops that are occurring at the end of October in Bristol and at the end of November in London. And if there are no questions, I think I'll just end with this from Donna Haraway, who wrote that it matters what matters we use to think other matters with. It matters what stories we tell to tell other stories with, what thoughts to think thoughts, what descriptions to describe descriptions. It matters what stories make worlds, what worlds make stories. And thank you to Bristol Tech Festival.
Thank you.
Thanks.
Thank you so much.